Okay, in this situation, we're going to try to find the equation of this reciprocal function graphed in front of us here. So first things first, it's not the basic reciprocal function, because our asymptotes aren't the x and the y-axis, and we don't have 1 and 1 as an ordered pair, and -1 and -1 as an ordered pair. So we must have a transformed reciprocal function here in front of us. So to transform any function, including the basic reciprocal function, we can multiply that function by some number a. Of course, if a is negative, it can also reflect the function as well. And if we want to move our function left and right, we'd have to put an x minus h in here. Remember, that is the tricky one. If h is negative, it shows up as a plus in our function translated left. If h is positive, our function translated right. And k is a little more intuitive. If that number is positive, our function was translated up. And if it's negative, translated down. Okay, so we have some information here I think is a reasonable guess. Let's say our horizontal asymptote is here along y equals 4. Assuming we have integers, of course, which I think would be a reasonable assumption. And it looks like a reasonable guess of our vertical asymptote, division by 0. Again, if it's an integer, must occur at -2. So right now, I know my h value and my k value. So I can rewrite this, and I'm not going to worry about the a quite yet. So how do I get division by 0 at -2? Of course, that has to show up as a +2 on the bottom. Space that a bit more. So if I input a -2 in for x, I do get division by 0. And our horizontal asymptote, of course, is always that constant tacked on at the end usually, which is +4 here in this graph. Okay, so that's 2 pieces of our puzzle. We still have to find our a value, and to do that, we just look for some ordered pairs on our function, typically at a lattice, using lattice points, of course, which is going through your x and your y parts of your graph paper, through your grid lines. And we got all kinds of options. We have 2 on that branch, and we have 2 ordered pairs on this branch. And I think I might, and of course you can use any of these. And again, I would stay away from fractions because that would involve some guesswork. But if I use this ordered pair, that would be x is 0, producing y is 3. Of course, that's an ordered pair, so that's x first and y second. So I can input this information, a 3 for my y, and rewrite the rest. I guess all in white at this point. Of course, my x value is 0. And by putting 0 in there, I don't have to think very much. It's just simply going to be 1/2 or a half. And we have a half times a. A times a half, which of course is just a over 2. So 3 equals a over 2 plus 4. And so we don't have to tinker with fractions. Let's double everything. By doubling this term, of course, that's just going to be a. And if we double 3, we get 6. And 2 times that, of course, is a. And then we have 2 times 4, which is 8. So that would mean if we subtract 8 from both sides, we'll have a equals -2. So we now know our equation. Of course, I can look right here. I know my x, my h, I guess, and my k value. We just had to figure out what a was, and we have a equals -2. So just rewrite that with a -2 out in front. And with a 1 over x plus 2, that would give us the vertical asymptote that's notated above there at x equals -2. And of course, plus 4 is our horizontal asymptote. And if you're unsure of that, a good idea would be to try some x values at those 4 lattice points. Double check your equation. I think I'll just check maybe one of these. How about we check? I need a pencil here again. If we check this value at -1 and 2, if I input -1, I'm going to get 1 over 1. Of course, that's just 1. Timesing that by -2 doesn't change -2, so I get -2 plus 4, which is indeed the correct y value. So take some time to check 1 or 2 of those ordered pairs, and you can be 100% confident in your equation. So there it is. A little bit trickier than graphing a function is determining its equation from a graph.